In this video, we're looking at connecting two half cells together. Okay, so we've got the reduction potentials here of a zinc half cell, which written as the reduction potential here, it's got an electrode potential of minus 0.76 volts. And we're going to connect this up to a copper half cell, which has an electrode potential of plus 0.34 volts. Overall, we are looking to see a reaction between the zinc solid, which is going to deliver electrons to the copper 2 ions to make copper solid and zinc ions. Okay, and what we predict is that the EMF of the two half cells connected together will be plus 1.10 volts. So here's the actual physical setup of the cells. So here on the left hand side we have our zinc sulfate cell. So we've got our zinc sulfate solution in our beaker. In here we've got our zinc electrode. On the opposite side we've got our nice blue copper sulfate solution, copper 2 sulfate, and our copper electrode. Both the solutions are 1 mole per decimeter cubed in concentration, so that means we've got a 1 mole per decimeter cubed concentration of zinc ions in this beaker here, and a 1 mole per decimeter cubed concentration of copper ions in this beaker here. We have cables linking our electrodes to our high resistance voltmeter. So the red lead comes from the zinc to the voltmeter, the green lead goes from the voltmeter to the copper electrode. We complete our circuit by using our salt bridge. Our salt bridge is just a piece of chromatography paper or filter paper, and we've soaked it in potassium nitrate solution. So whilst the electrons flow around the wires from one pot to another, ions flow across the salt bridge. Okay, so we've predicted that the EMF of the cell will be plus 1.10 volts. That is because we reverse the sign of the most negative electrode potential and add that to the positive electrode potential, which gives us this overall equation here. Okay, so if we turn on our voltmeter, and there we go, we've got a reading of 1.00 volts, which it's not a bad estimation what we're expecting. Now part of this could be because of the temperature. Trying to show the temperature now. The temperature here is about 18 degrees in the lab. Okay, for us to have the standard electrode potential, we would need a temperature of 25 degrees or 298 Kelvin. Lastly, we represent our cell using the IU pack nomenclature here, where we have our negative electrode, our zinc, on the left hand side, and then our positive electrode on the right hand side. Okay, the negative electrode, that is where oxidation occurs, so the zinc turns into zinc plus ions. On the right hand side, the copper 2 ions convert into the copper metal. Okay, we have a phase boundary represented by a single line, and we've got the salt bridge being represented by the double lines. And that's all I'm going to say for this video. Thank you.